Hello and welcome to Field Trip Friday. Today we're going to talk about plate tectonics, and in particular we're going to talk about our own plate tectonic province. As you learned this week, you looked through kind of where our major plate boundaries are, and then you hopefully noticed that Utah is sitting kind of in the middle western side of the North American plate. And so as you think about where we get most of our plate tectonic activity, it is along those boundaries, right? That's where we're expecting to see lots of faulting, lots of earthquakes, lots of volcanoes. But kind of strangely, where we're located in Utah, we know that we have active earthquake hazards here. So why do we have hazards in Utah, even though we're really far away from the edge of the North American plate? Well, the answer to that is the plate tectonic province that we are located in, which is called the Basin and Range Province. Is being pulled apart and thinned. And so we do have our closest plate boundary, which is the San Andreas Fault, which sits along the western edge of North America, right? It runs all the way along California, and it's the boundary between the North American plate and the Pacific plate. And that boundary is a strike-slip boundary. So we're getting strike-slip movement of the Pacific plate is kind of moving to the northwest as compared to North America, which is going towards the southeast. And so that movement causes earthquakes in California. That movement also is causing this whole part of Western North America to be pulled apart. And so where we're located used to be a very, very high, thick-crusted mountain range between about 50 and 100 million years ago, which I know seems like a long time, but geologically speaking, the crust still kind of remembers, right? It used to be really, really thick, and we used to be pushing on it really hard. Well, about 40 million years ago, we stopped pushing on the side of North America, and we started moving the San Andreas Fault system. And so when we stopped pushing, what that meant is we had this big, thick crust that's now not being held up by anything, and it starts getting pulled apart. And so that's what the Basin and Range Province is, where we're located. Our crust is being pulled apart and thinned. And so what that means is as we stretch the crust, we're going to be forming normal faults. So if we remember in a normal fault, we have our hanging wall is dropping down as compared to our footwall. So as we pull that crust apart, we're constantly dropping our basins a little bit lower as compared to our mountain ranges. And where we're located here, we have the Wasatch Fault, which bounds the Wasatch Mountains, and that forms the eastern boundary of the Basin and Range Province. So we are the big bounding fault on the eastern edge of this entire tectonic province that spans from here to California. So the Sierra Nevada is the other side of the Basin and Range Province. And if you look behind me, you can see multiple discrete mountain ranges. So you can see Promontory Range, which is behind me. You can see Fremont, Little Mountain, and we can see even mountain ranges that are farther out into the West Desert. Each one of those is a little isolated mountain range that has a normal fault sitting next to it that is bounding that range. And so every time that fault moves, the basin drops down. And so we have that constantly happening over millions of years, and we get these really steep mountains that are all bounded by active faults. And so that's why we have active faulting in this particular area, and our style of faulting is going to be normal faulting because we are stretching our crust apart and we are thinning that crust.